Hello, David. Hello. I still got my mic and my little cards, because if that goes on the floor. Anyway, thanks very much, David, for being with us at the 3DX Forum. So give us an inkling into NAAREA's background and its vocation. Well, first off, thanks very much for welcoming me here. So our company's vocation is very straightforward. We want to save the world. There it is. Well, that's a good start. It's a bit of a challenge, though, I would say, isn't it? All right, so before you ask me how we're going to do that, perhaps we can look very quickly at this short film, and then you'll understand what it's all about. Okay, let's have a look.
NAAREA a pour ambition de participer à la décarbonation de la planète et de fournir la demande énergétique qui va être colossale dans les 30 prochaines années. La contrainte principale, c'est le temps.
Nous utilisons la suite 3DEXPERIENCE de Dassault Systèmes qui fournit l'ensemble des outils de traçabilité, d'ingénierie et de calcul pour la conception du réacteur.
NAAREA est une jeune entreprise française qui développe des microgénérateurs nucléaires de 4e génération, sel fondu neutron rapide, pour produire de l'électricité et de la chaleur à partir de déchets nucléaires.
On est sur un projet qui est extrêmement ambitieux, on veut le faire vite, sans perte d'informations, et en garantissant un bon niveau à la fois de traçabilité et de sûreté.
La plateforme 3DEXPERIENCE, c'est la colonne vertébrale du projet sur plusieurs décennies. Le jumeau numérique va permettre non seulement la conception, la mise au point, mais va permettre de supporter les démonstrations de sûreté et de sécurité, la fabrication, le déploiement, l'exploitation, la maintenance, jusqu'à la fin de vie du réacteur.
Le jumeau numérique chez NAAREA repose sur 3 piliers. Le premier, c'est la partie modèle 3D du réacteur et de l'ensemble des pièces, sur lequel on va ajouter l'ensemble de ce qui est suivi de modification et suivi de configuration. Le deuxième pilier, c'est la partie simulation. C'est-à-dire qu'on va faire des calculs mécaniques, de thermo-hydraulique, de simulation de dynamique des fluides, de la neutronique. Le 3DEXPERIENCE permet de faire directement des simulations sans avoir à passer par des étapes assez chronophages de conversion de données. Et le troisième pilier, c'est la partie traçabilité des données d'ingénierie, traçabilité des requis et des exigences. On vérifie que ce qui a été fait, ça a été fait correctement par les personnes qualifiées et que ça répond bien aux besoins.
Un jumeau numérique permet de gagner de la vitesse au démarrage et permet d'accélérer le déploiement. Nous avons réussi à développer la première version du jumeau numérique en seulement 18 mois, ce qui est un record.
La solution cloud faisait qu'on avait dès le début un outil complet sur lequel on pouvait directement travailler. Il n'y avait pas besoin d'avoir monté des serveurs et un service informatique en interne.
NAAREA, c'est un projet multisystème extrêmement complexe. Vous avez tout un tas de différentes disciplines qu'il faut pouvoir agréger ensemble.
En termes de systèmes, il y en a à peu près une trentaine, mais chaque système est ensuite subdivisé entre 5 et 50 sous-systèmes, donc on a plusieurs milliers de pièces. L'ensemble de l'ingénierie travaille sur la plateforme de 3DEXPERIENCE qui permet de faire de la simulation système. Le fait d'utiliser 3DEXPERIENCE permet d'avoir un point d'entrée unique, à savoir l'ensemble de l'information est sur une seule plateforme et c'est elle qui fait foi.
Le rôle d'un système, c'est de savoir paramétrer l'ensemble de la plateforme 3DEXPERIENCE et de pouvoir l'agréger avec l'ensemble des outils de calcul scientifique. Un système a permis de mobiliser en un temps record des ingénieurs de très haut niveau qui permettent de réaliser cette intégration. La 3DEXPERIENCE permet de garantir une plateforme numérique commune à l'ensemble des collaborateurs et permet ce qu'on appelle la continuité numérique, ce qui est absolument capital sur un projet de cette complexité. Tout projet complexe aujourd'hui qui veut démarrer doit avoir son jumeau numérique.
All right then. So I think you're going to have to fill in the gaps on that one. How are you going to save the world? Even though I think I've got a little idea. Well, we started all this in 2020. We became conscious of something that we already knew, of course, but we became mindful of something that's crucial. In other words, everything boils down to energy. We're here thanks to power, aren't we? You know, if we have people online, it's thanks to electricity, the presentations, even myself. When I move around, I actually generate energy. So the problem is, energy is 72% of CO2 emissions, and that boils down to 3 sectors. Industry, mainly 3 sectors anyway. Industry, transport, and construction. That's what we mean by the industrial sector. But if we get the fossil fuels out of that, well, we reduce CO2 emissions on the planet by 60%. So how do we go about getting fossil fuels out of those three sectors? Well, straightforward. We need to provide energy source which is steerable, clean and accessible, cost and quantity-wise, and closest as possible to the users. Now, you might say that, but it's not as straightforward as that. I suppose, what is this energy and how does it materialize? Well, that's why we put together a small nuclear reactor, because that way you can produce quantity power. It's clean, but also it needs to be ultimately safe. So we chose molten salt, which is self-regulated and therefore safe. And then we also want to use fuels that are nuclear and that have been used. No, nuclear waste, basically. We want to use the nuclear waste. All right, so that's technology, first point. But it also involves another point, producing things in series, 150 per year when we have reached cruising speed. So we'll have that approach. And then third, a business model. We're not selling the containers per se. We're not selling the containers to our customers, but we are offering them as a service, energy as a service. So we keep the containers in-house and we offer this energy. So it's a turnkey solution, operations, monitoring, maintenance of the reactor and what have you. That's right. So today we do everything from design all the way through to mothballing, because in nuclear that's very important, the dismantlement process. We have 20 or so studies ongoing with some industrial players. Some are in the public sphere. You may have seen the bank holiday weekend news, ACC, automotive cell company, that appeared on the news. It's a big battery that's set up in the north of France. We work with them on potential for implementing between 2 and 4 containers from our system to offer them support in their manufacturing ramp-up. Because, you know, a container is huge. No, it's not. It's 40 feet. So you've got one for production, for nuclear production, and another one for heat and electricity generation. All right, then how are you going to sell these reactors, these mini nuclear reactors? Well, we're going to be working with these industrial players. We're going to be setting up the systems on their premises. And then we have a contract signed with them. So we're out of any speculation. And they have access to all energy. In other words, electricity and heat, which comes out of the system, and that they can then use for whatever they want to use them for. So where did this idea come from, if I can put it that way, of these small reactors? We talk about AMRs, don't we? Advanced Modular Reactor. Absolutely right. AMRs, that's right. So that's the technology which is much better than former iterations. And you can use waste as a fuel. We use AMR, extra small advanced modular reactor. Yeah, so that's what we do. All right, so our starting point was the fact that the climate is a sense of urgency there. That goes without saying. But also, we need to think about the economic sense of emergency. You know, an urgency. We talk about AI. These giants are going to be turning up between 2050. Electricity consumption will be doubling, even more in the world, and not to speak of heat. So there is a energy sense of urgency here, but there's also geopolitics. Energy, obviously, you know, Renault, I heard earlier on, was talking about something similar. A number of corporates are saying that we need to access energy and raw materials. That's what it's all about in the future in industry. And of course, that involves geopolitics and therefore sovereignty. We have 4 major hubs, the US, Russia, China, and Europe. And it so happens that in Europe, in all likelihood, we have the best team in the world on nuclear. We've made vast inroads, or we did so in the 1990s. We'd be ashamed to lose that competitive edge. All right, so these nuclear reactors and these mini nuclear reactors, it's all about cogeneration. Is that right? Can you tell us more about that? Yes, that's right, Fred. Cogeneration, but multiplied by 10, if you will, because, well, it's cogeneration because it's waste to energy. We're going to get nuclear waste and we're going to extract power out of that. But it's cogeneration multiplied by 10, if you will, because if an industrial company doesn't need heat, well, we can use that heat, that residual heat, to do direct air capture. So we capture the CO2 which is in the atmosphere, and that CO2, it's important to capture it because we'll need it in industry, in particular with I-fuels. So we want to have CO2 negative. So we actually, rather than producing it, we're extracting it out of the atmosphere. How many megawatts does an ex-AMR produce? It's always a bit tricky to answer that because, as you would have understood, we make heat, electricity, and we do 3 types of heat: high, medium, and low temperature. And our customers can switch from one to the next. We talk about equivalent, 80 equivalent megawatts that can be used in those 3 buckets. All right, let's talk about electricity. How many houses are you going to offer electricity to? So if you want to make electricity, but not high temperatures, but we can make low temperature, but it's about 40 megawatts, about 100,000 people city, 200 electric buses, 5,500 tons of hydrogen. It's the biggest boat in the world that could go around the world as well, and 80% of industrial needs, factory needs, because we can modular things and adapt, therefore, to tailor to the needs of these companies and these factories. It's interchangeable. That's right, we can add on or remove from this modular offering. Now, we want to develop things over 40 years. This is the lifespan of an ex-AMR, and it really depends on the various maintenance solutions that we can have, refurbishment or what have you. But, all that in a highly safe apparatus. All right, I'd imagine that the challenges are quite huge, no? Well, look at this endeavor, 230 employees in our company. So recruiting 230 people in a space of 2 years, that's a challenge in itself. We often say that we eat challenges for breakfast, yeah? Because we have so many. But really, it's just 3, really, it comes down to. There are 3 challenges. The first one is time. Second is time. And third is, well, you've guessed it, time. It's pretty straightforward, yeah? Yeah. So why time? Well, because we talked about the climate is pressing, economics are pressing. We deal with this day in, day out. Third, time is a race against, we need to have these permits, yeah, because we're nuclear. We need to have these safety and security permits because we want to be ultra safe. So why is it a time against the watch? Let me open a parenthesis. The French nuclear authority is fabulous. Their work is difficult, but it's highly responsible. But they also need to tailor to the new needs of new nuclear companies such as us. We started off in September, but they adapted their processes, which is even more demanding with us than others, I would say. But they really want to make sure that things go as quickly as they need to go. All right, so you're running after time for climate reasons, for the economic reasons, and for the regulators. Well, you obviously think about digital twins, don't you? That's right, we saw that in the film. For us, it was key. And right from the outset, we on board with that because it's an accelerator. Yeah, it accelerates through a number of phases. Right at the beginning of this endeavor, we'll talk about that afterwards possibly. But it's important for design. We have electronics, mechanics, thermodynamics, fluid mechanics, and all that. That's baked into the process right from the start. We can also run simulations on the systems that we couldn't do in real life, or even in the prototype. And it's an accelerator because you can trace things exhaustively. We talked about single point of truth, but here we can have all the versions in the world, all the documents, all the simulations that have been done thus far. And that's important for the regulator because we can track and trace what we've done. You also talked about 230 employees, is that right? That's right. And your team, I don't know, is extraordinary, is it? Well, in actual fact, it's true. We're a fabulous team. 1 or 2 of them are in the auditorium, it must be said. But, our team is brilliant because we're lucky enough to have combined 2 things. First, we have the fact that our system is more akin to a plane engine in terms of its complexity. But we don't only want nuclear skills in our teams. We went off to get skills in automotive. He's even in the room. An architect, an automotive architect. He joined us right from the outset, thinking about design to manufacturing, particularly on that particular field. And we went to get people from aeronautics. So we had nuclear and aeronautics clubbed together, which meant we could, in the space of 18 months, develop this digital twin process. We had people who'd already seen how good it was. And it was the first digital twin in civil nuclear industry. So you're talking about this vast gamut of skills that you have, but there's also an intergenerational flavor to it all, isn't there? Yes, that's right. Nuclear has been hibernating a bit, hasn't it, for a long time, and France was a major nuclear expert, if not alone in the world. I mean, and these people aren't necessarily very young anymore. So we've achieved a number of these people who were involved in programs that were ultimately mothballed, and some of them are in their 80s, therefore. But we combined their skills with young blood, and this is crucial for a company. We often say that, you accelerate young people's experience and you rejuvenate our seniors because they have that spark in their eye, because they find the project fabulous. So the 3DEXPERIENCE platform played a key role, therefore, in accelerating your project development. Yes, that's right. I mean, it plays and will play for many years to come a key role. Primarily, it is the place where we can all work together on the same thing, the same artifacts, the same objects, the same data foundation. That's crucial. And the life cycle is 40 years, you said. So the partnership with Dassault Systèmes will last at least 40 years? Well, it's our hope, yeah. Yes, yeah. I mean, this is a project which will be here for the long term. We're right at the outset at the moment. We've done design, starting to work on two other spheres. The first, and I have one person in the crowd who deals with this, looking at assembly, AI, and how do we assemble these reactors in the production line, and then building in real data that comes from the tests, the scientific tests that we've done, and the prototypes, because the whole point about a digital twin is to combine all that. And then thinking about the lifespan, there'll be other phases on the way. But over and beyond a tool per se, a digital twin is a way of thinking, of working, which is very much built into our ways of working, if you will, the way the companies run. So you said that you interact with a number of industrial players, you work quite obviously with the regulator. How does the market reacting? Will it fly on the market? Well, yeah, it's going down very well. A very positive reception. And I think what we can see is that we've gone from mindfulness, if you will, in terms of the economy, in terms of the climate, to taking a stance. Companies, industrial companies, have really shown a resolute desire to execute on this, to walk the talk on this, and designing the offering and setting up this system. This has been done in conjunction with these companies to make sure that we're properly tailoring to reality. So a very positive reception. So what about 5-10 years down the road? What will things look like? Over and beyond recruiting many more people, because we need more and more people, our objective is to be able to sell our first systems in 2030. It might seem a long way away. It's in industry. It's not very far away, particularly in nuclear. So we're going to have a hot prototype with the actual waste in it between now and end of 2027, and then we'll have a cold prototype. So, we're confident. We'll hit those dates. It's perfectly feasible. It's bold but feasible, and with our team, we'll get from A to B. All right, then. We've got 20 seconds. So, conclusion? What can you tell us? Well, first, I've got a bad news. NAAREA is not going to be able to save the world. But I do think that everybody here, all of us, can save the world. And what we can see, and what I can see, is that with our industrial companies, when we work with them, and we work with local authorities and regulated, where sometimes it can be tough, there is a glimmer of hope. There is a silver lining, a desire to take things forward, and scope, therefore, to live in a fossil-fueled world and to maintain our standard of living and offer it to other people in the world. A friend of mine told me the other day, you know, when I see this, your project, I think that the future is back. So that's my final word. The future is back. Thanks very much, David.
Chapeau. Merci.
I take my hat off to you. Well done. Thanks very much.